Welcome to this video on question number 3, paper 4, October November 2009, which is a request of Ria Hussain 1 2 3 4. Let's start. We are given 6 cards, 1 2 oh, yeah 3 4 5 6 6 cards, and they have numbers 1 1 6 7 11 and 12. In this questions give all probabilities as fractions. In part A, in part A, one of the 6 cards is chosen at random. Which number has a probability of being chosen 1/3? Now for part 1, we are given the probability as 1/3, but when we are normally calculating the probability, what we know is that if we have total 6 cards, the total comes over here, and if the total is 10 cards, we'll write 10 here, and what we are looking for we'll write here in the numerator, right? But in the answer we have is 3, so but we don't have total 3 cards, we have 6 cards. So from 1/3 we want to go back to the fraction which has a denominator of 6. So how can we do that? It's by multiplying with 2. So it means we have to multiply by 2 up, so the balance of the fraction is maintained. So this is what we will get. So the probability is actually this is the probability when it is simplified. Okay, so 2/6, when you simplify it you'll get 1/6. So now I know out of the 6 card which card have chance of having 2. So it's just this card. One has a chance of coming twice out of the 6, so we will write our answer is 1. The card is 1. So now let's go to the next part, which is second part of part A. What is the probability of choosing a card with a number which is smaller than at least 3 of the numbers of the other numbers? Smaller than at least 3 of the other numbers. 12 is not smaller than anyone. 11 is smaller than just 1. 7 is smaller than 2 numbers. 6 is smaller than at least 3 numbers. Yes, so I have 6. 1 is also smaller than at least 3 numbers, and this one is also smaller than 3 numbers. So I have, how many numbers do I have which are smaller than at least 3 numbers? They are 3 out of the total 6. So my probability is 3 out of the 6. You can round it off to 1/3 or something, but this will do. Let's look at part B. 2 of the 6 cards are chosen at random without replacement. When they say without replacement, it means the first when we are picking the number first time, the total will be 6, but when we are picking the second time, the total will be 5, because they have not replaced. When you don't replace, then you will be left with 5 cards. Okay, so that's why they write this one. So part 1, we have to find the probability that both numbers are 1. So for that one, when we have all 6 cards, we had so when we have all the cards, how many times number 1 is there? It's twice, and then they will not replace that one. Then how many times number 1 will be there? It will be just once, because 1 is already taken out. So I will have the number 1 card only 1 times. So the total will be 2/30, and this could be your final answer. That's perfectly fine. So now B's part 2. The total of the 2 number is 18. Now how can we get 18? 6 plus 12 is 18, and 7 plus 11 is 18. So that's the 2 ways we can get 18. So if I pick first card as 6 and second card as 12, I will get 18. Or if I pick first card as 12 and second card as 6, so that's 1. The other chances is my first card is 7, the other card is 11, or first is 11, the second card is 7. So and what you can notice is that all these numbers are just ones, so we can just multiply it by 4, because all they will have the same probability. You can do it, you can calculate all the probabilities differently, but you will in the end get the same answer anyway. Okay, so the probability of having 6 is 1/6 times 1/5, because chances of having 12 is just 1 out of the remaining 5 cards. So for this one you will get the same, because they all are coming just once. So what you can do to get the answer quickly is that you can just multiply it by 4, or you can add 4 times the same number anyway you will get the same answer, so it will be 4/30. Okay, now let me go to the next part, which is part 3. The first number is not a 1 and the second number is a 1. So first number is not a 1, so we have 2 ones, the other 4 are not ones, so I will have 4 out of the 6 is not 1, but the second one is a 1. I have 2 ones still there, so this will be my probability, so it will be 8/30. Part C. Cards are chosen without replacement until a card number 1 is chosen. Find the probability that this happens before the third card is chosen. Okay, what they are doing is they keep on choosing the cards until they choose they choose card number 1, and we have to find the probability that this happens before they choose the third card. So it might happen that I choose the card number 1 in my first chance or in my second chance. Okay, now what is the probability, but not in the third chance, I have to say before the third card is chosen. So what's the probability if I get the number 1 in my first chance? It's 2/6. Yes, because we have 2 ones out of the total 6. But what is the probability of having the card 1 chosen at second chance, which we already calculated in our previous part, which is this, right? Not having 1 in our first try, but having 1 in our second try, which was 8/30, right? Or you can just, if you want more working, you can just write the same thing over here. Okay, the same thing. So, or you can just copy it from up and you will get what is 3/5. Without rounding, you can get 18/13. Okay, sorry, without simplifying. Let's have a look at part D. A 7th card is added to the 6 cards shown in the diagram. The mean value of the 7 numbers on the card is 6. Find the number on the 7th card. Now, if you know the formula of the mean, it should be really simple. What mean is, we have to add all the values. So okay, 1 plus 1, the other card was 6, the other card was 7, then I had an 11 there, then I had an 12. They added one more card which I don't know, but if I divide them all by 7, the total number of cards, what I will get is 6. I'll just simplify this. Adding them all will give me 38 plus x. 7 will be multiplied with 6 will give us 42. So x is equals to 42 minus 38. Finally, x is equals to 4. Thanks for watching.